Alright, good evening everyone. It is 9:29. I'm just going to check out the setup to make sure that everything's streaming. So give me a moment to check on that. I have a computer set up over here to double check that the stream is working. Alright, good evening everyone. Yeah, we're good. Okay, turn the volume down on that. Alright, well, we're going to try this out. It's 9:30, and what we're going to do tonight is try to look at a few objects through the telescope I have sitting outside. It is currently sitting just outside the door to my left, and I have about a 10-foot USB cable connected to the camera. So we're just going through a window, and I can sit inside in the warmth, and the telescope can be outside. I haven't done much to prepare tonight because the goal here is to show a few objects, but also will learn some things. So if it's something you're new to, which really I'm new to it, I've only done this probably 10 times. If you're new to this, you can see what's involved. A lot of the live streams, they kind of skip the part of the alignment and all that, and they get started into the actual viewing. So I'm going to give kind of this part. So if you're just looking for viewing the objects, you might skip ahead or go brew a cup of coffee or something like that. Hopefully we'll be on for maybe 45 minutes to an hour. We'll see how long it lasts and how it works. But we are going to do some things that I'll have to step outside for just a moment to get started. But once we get everything aligned and set up, at that point there will be no need to get up from the chair. So let's move this off of the screen. I noticed that this video is here. Okay, great. We have the software. So I guess I should introduce myself. My name is David Manuel, and we're coming from Knoxville, Tennessee tonight, about 2 miles east of downtown Knoxville. The skies are Bortle 6, so there's a fairly good amount of light pollution, and that's why something like this is very helpful, because with a telescope and just the naked eye, you won't get to see as much because the background light will drown it out. There's some street lights around, so it's hard to get your eyes dark adapted in the yard as well, and it takes up to 30 minutes to do that. So this method of viewing is very helpphul to be able to see things that you wouldn't normally see with your naked eyes, even in really good dark skies. What is this not? It's not astrophotography. A lot of the very cool pictures we see online, people will do similar. It's very similar to what we'll be doing tonight. They capture it in a similar method, but they may capture it for longer periods of time, do a lot more post-processing on it to get those really nice pictures. They also spend a ton more money on their mounts and some of the equipment to get there. And tonight's setup, as we'll see in a little bit, is really modest in terms of an astrophotography or EAA setup. What is EAA? What I've been describing to you is electronically assisted astronomy. So let's go ahead and get started, and we'll see where we go from here. On the screen tonight, you'll see on the main window on the left is SharpCap. It's a capture software. It takes the images in the camera, and we will manipulate the images there. So we'll spend most of our time there. At the top right is a program called Stellarium. It's basically like a planetarium program. We'll search through that software to just take a look at targets that we want to go to. It can control the telescope, but for tonight, just to be on the safe side, we're going to control the scope with the SenScan app, which is the bottom right-hand part of the screen, and we'll do all the alignments and controls from there. So that's what you are seeing on your screen, and of course you are seeing in the bottom right-hand corner. I am there, my mugshot. So let's start off with an alignment. Before we are going to start tracking stars or anything we're going to look at, we've got to align the scope, and so it'll know where it is. So let's get started. We're going to do a 3-star alignment, and we're going to pick, I'm going to go with Jupiter, Razelhague, don't know how to pronounce that, and Alpheratz. We're going to start there, and I'm going to get up and go outside. I'll probably have to unplug the camera for a moment just to make sure we don't stretch the cord out. So let me hit begin alignment and I will be right back. Alright, with any luck, it looks like I did not get Jupiter into the center. I do see the focus is a little off, so what we're going to do, I'm going to head back out and try to recenter Jupiter again. Just to explain what I'm doing, I'm actually going to eyeball the first one, which is Jupiter. As soon as I get it centered, the rest of them I should be able to do in the software only. But this one requires me to go back outside, so I'll be right back. Alright, looks like we didn't quite get there, but let's turn some of the settings down. We might try something different. On a normal evening, I would get this first try. But go figure. On a live stream, you might miss it. So let's turn the exposure down so we can see. And see, we're still out of focus a bit, so I'll work on that while I'm out there as well. So let's go for another try. Be right back. Alright. Just needed a little trial and error. So now you can see Jupiter. We're still a little out of focus, but that's okay. We'll work on that in a moment. We're going to place some crosshairs on the screen and move the mount around. And turn down the exposure some so I get better response on the image. There we go. Now I can see the movements in almost real time. Just try to get that centered as best I can. The more accurate that I am here, better off we'll be later. That looks good. Okay. Well, hit check mark, and now we're going to go to the next star. We'll watch and see how close we get to this one. If we're lucky, I'll only have to pan here and won't have to go back outside. So it looks like not quite. Let's go back to Jupiter for a moment. We may not be able to do that. I see we have a couple of stars here on the screen, but I did not see the one we're interested in show up. So we're going to add some exposure and see what we have here. Probably should have focused with Jupiter in the screen to begin with. That way I could have done a plate solve here, and we'll talk more about what a plate solve is and how that's helpful here in a moment. So I'm going to tell you what, we'll go back and we will try Jupiter again and see if, see there's the star. It was really close. As you can see here, this is why a lot of people will leave this this part out of the live stream, because it can be a little problematic. Some trial and error. But it knew where Jupiter was, so that's good. We will recenter, and this time I'll do a focus before we leave Jupiter. We'll get it in good focus, or close enough that we can do a plate solve on the next one if we need to. Alright, so getting a focus requires me to do one thing, and that is I've got to put a mask. It's called a Batinov mask, and it will create a pattern. We're going to zoom in a little closer so we can see this pattern. And you'll see as soon as I put that on the change, so I'll be right back. Alright, now that I have the mask on, we can see this shape is, I'm going to turn up the exposure here. There we go. We're actually looking for a symmetrical shape here, and so we're leaning to one side. You'll notice as I turn the focus knob that the middle, there are really three spikes, the middle spike will move toward the center, and as soon as it's centered we'll have a good focus. So I'll do a trial and error and come back and take a look at the screen, but this shouldn't take too long. We're getting closer. Almost. Alright, that's just about perfect. So I've removed the mask, and that should be the last time I need to go outside for the evening. So now that we have Jupiter, we're going to center it again. And on a side note, you can see it looks like 3 of the 4 moons, if there are more than 4, but the prominent Galilean moons. Great. And before we tell that, let's pull the exposure down so you can see more. Not a lot of detail to see on Jupiter because I don't have very long focal length that would enable us to see it, but why not give it a try for a moment while we have it in view. Yeah, not a whole lot. I need a larger image from the telescope, and there are ways to do that, but I don't have the telescope set up for that tonight, so we're not going to see much detail at all really there. But you can see the disk, and then of course the moons as I turn up the exposure. So let's go ahead and tell the mount that we are centered and move on to the next star, and hopefully this time it'll be easier to see or to be closer. Wait, it's alright. So not there, but we have a tool at our disposal this time that I should be able to use that I wasn't able to use last time, called plate solving. And it's a piece of software I've installed, sort of like a plug-in to SharpCap, that will read all the stars on a screen and determine where it is and then recenter. So we'll look here and see how many stars we have. We're going to turn the exposure up a pretty good amount. I'll do a 5-second exposure and see. Not very many stars, so hopefully we can plate solve with that many. We're going to give it a try. That's quite. Let's see what happens. So the progress is up here where it says solving frame, please wait. It's going to take a capture and analyze. And my daughter's yelling toward me, so hold on a second. Alright, I'm back. We'll see if we get a solve here. It seems like it's taking a bit of time. There it is. I was looking through the indices, I suppose. And it doesn't look like it's having much luck there. Let's move some of the histogram around. Yeah, we're not going to get many more stars out of that. So I'm afraid that the plate solving is not going to help us here. We can also try something else. We can look around. See if this will help. There's a spiral search. I'm going to turn the gain all the way up. And we'll see if this helps if we get lucky and find it. And really what's going to happen is it's just going to do a spiral around that area that we were searching in. Turn this up to... Let's try again. So still not much luck. So we'll cancel the plate solve and let's try. We'll try a 2-star alignment. We know that it knows where Jupiter is, so that's helpful. So we will Jupiter and go with Mars. We'll see if that's any better. So I apologize for the technical difficulties. If it had been last night, I had this done quickly in a few minutes. And we would already be observing. Oh, it looks like we didn't get the scope to move. On this one, you have to move it yourself. Well, shucks. We'll try the 3-star alignment again and use different stars. Let's try it this way. Let's see if we can't get a different star. Oh, okay, so it definitely knows where Jupiter is. It went right to Jupiter. So we'll do a small correction here, not much. We'll do a small one. And we'll try Mars. See if we can get that. As you can see on the screen here, for Stellarium, it's actually showing where the telescope is pointed. So we're having to go a good ways across one side to the other to get to Mars. Are we going to get lucky? Man, I didn't see anything, although I saw a few more stars, so a plate sol might work better in this case. So we'll try a plate sol again. Let's see if we can't get this to work. And I'm actually turning the exposure up to past 2 seconds, and you can see more stars. Let's see how the plate solving does here. So we'll click on that, and once again you can see this yellow bar at the top of the sharp cap screen. It's reading the file, and then it will start searching. And usually within 20 to 30 seconds it'll know where the scope is pointed. But every now and then I throw one at it and it just doesn't know. There we go, this one found it. So we were just 0.73 degrees off. And it will actually recenter the scope based on where it's supposed to be. Perfect. So now let's turn the exposure down and we'll center Mars. There we go. And let's get the last one. Now this third star will probably be close, since we have 2 already programmed in. The map that it's generated of the sky is going to be more accurate already. So for the third one, you should hopefully get luckier. We're just about 20 degrees away. There it is. The good thing is it went across the field of view, so I know which way that I can pan the. We're going to go up. We're going to turn this up a little bit. Go up a bit and then bring it back. There it is. So we'll talk about the equipment I'm using in a moment and why the equipment that I'm using actually makes this more difficult. And the reason I'm trying to get a 3-star alignment is I want the best tracking I can get out of this mount. Again, I'm using very inexpensive, relative to the hobby, equipment, and when you use inexpensive stuff, you have to deal with some issues. Alright, we're going to turn our game back down. Now, what did I do before we got started today? Real quickly, I'll run down. I set the telescope up and leveled the tripod, and then I did take some dark frames I'll talk about what dart frames are later, but I went ahead and took those because they take 6 or 7 minutes and no one wants to sit here waiting for the dart frames. It's probably been bad enough that you've been sitting here watching me try to align the scope. So, having said that, let's try our first target for the evening. I want to get it first because it's the setup I have here at home. Basically, since I have the telescope outside the door or outside the window, the house is immediately to the northwest side of the telescope, and then I have quite a few trees on the south and southeast side. And Vega and the general area where the Ring Nebula is located will be setting across the house in just a few minutes, so we'll grab it first. So to begin with, let's learn a little bit about SharpCap. You'll see this field called target name. Later on we'll save our image, and so this basically tags the image with something. So I'm going to call it M57 for the catalog that this object belongs to, and let's go there. So now I'm going to go over to the SimScan app that I was just doing all the alignment in. Again, I could do this in Stellarium, and let's look real quick. I'll show you where we can find. We're at Altair now, so if we look over here, Vega and the constellation of Lyra, this is where we're going for. The Ring Nebula. It's right here. So that's where we're going to go. Oops. Let's click on it here. It's a planetary nebula, and it is magnitude 8. Let me go ahead and get the telescope heading that way while I talk. We'll go there. This is a nebula that was formed when a star exploded, and what you're seeing is basically the remnants and the outer shell and shock wave expanding over time. So let's see what we have here. It doesn't look like we quite got right there, but we do have a few stars in view, and we can do the plate solving, which is really, did I say that? Hold on a second, we may have gotten a view. I just didn't have this turned up. We're close, because I think this star is one of maybe Sulfat or Chiliac. It could be one of those two stars. Let's go ahead and do the plate solve. That just makes it easy. With that many stars, a plate solve should be pretty quick. And I have a child calling again, so hold on just a moment. I'll be back while that's plate solved. Alright, I'm back. We can see the Ring Nebula did make it, so we're going to go ahead and center that and tell the software that we found it. And now that I'm exposing at 1.2 seconds, I have to sort of wait for these movements, because this nebula is so faint it would be hard to see it with short exposures. We'll give it a little more. We're almost there. And I like to do this at each object so that I continue to build the sky map for the mount. Alright, there we go. To tell the mount, we're happy with that. And now let's change some settings here. We're going to go for a 10-second exposure, and hopefully that'll be good tonight with this mount. We'll see how that works without too much trailing in the stars. Okay, perfect. They don't look too bad at all after 10 seconds. So we're going to do in this software start stacking, and this is going to take quite a few images, and continually stack them on top of each other over and over again, and it helps get rid of the noise in the background. So we're going to start this live stack, and this is where having the name important. This software wants the name to be already there. It's going to use it. Let's clear that one and start fresh. Alright, there we go. It's going to reset some of these settings from the last time I was working on this. And there you go. So you can see there in the center of the screen. We have it's a really nice picture. You can see the star there in the center, and I'll blow it up a bit just so you can take a peek at it. So this is really what we're talking about in electronically assisted observing astronomy. It's because we are using the electronics to basically aid our eyes. If you were to look at this through a telescope, through this telescope in fact, you would be able to see it tonight. It would be more of a greenish hue, just a light pale, and you would have to know where to look for it. It wouldn't be apparent as it is here. And so let's change some of the histogram. Change some of this while we're. Oh, I know what I did. Let's reset this one. We have too many histograms going here. There we go. I was wondering why we had so much white in the image. Oh, that's nicer. Yeah, that's much nicer. When we look at the bottom of the histogram, we see that the red, blue, and green aren't necessarily aligned with this middle white line. And I know that there's a science to this, and interesting enough, I'm distracted at the moment because it sounds like someone's cutting lumber outside. But hey, I live 2 miles from the center of the city, so what would you expect? But if you hear that sound, it's because someone's cutting lumber. Back to astronomy. The 3 different color levels here are separated, so what I like to do, and this is just my trial and error, I try to line them up so it looks like red is underexposed where green and blue are overexposed. So I'm just going to add a little bit of red to this to line them up some, get them together, and then we'll continue adjusting the histogram and all the levels to my liking. This is probably one of the better pictures of this object that I have obtained. It looks like the tracking is doing better, so all of that time that I spent doing the alignment was time well spent. What I'll do, I'll likely stack 30 frames or so. So we're looking at 5 to 6 minutes in a stack. Some people go longer, but I usually get bored and want to move on to something else in that time frame, especially if we're going to do this online and you're wanting to see what's next. But let's zoom out at 100%. Yeah, definitely we're doing good on drift, because the drift graph, well, that looks bad, but I think it's doing well because we only have a small black bar on the left and a small black bar on the bottom that would indicate that we've drifted a tad and it is no longer collecting data from those edges of the picture. So I mentioned earlier that I've put dark frames on this, and you can add dark frames in this area, and I shot them before the session tonight. What a dark frame is basically you take your lens dust cap, put over the telescope, and you change the settings to mimic what you would be using for the actual capture. And you want all of the temperature and the parameters to be the same. So I did this just a few minutes before the session, because the temperature will affect how many pixels they call them hot pixels, will show up in the background of the image. And these chips that the image is falling on, they'll just have these pixels that'll turn on. In fact, let me see if I can turn this off so that you can see what it would look like without it. And you don't see them too bad, but they show up. And what it does is basically, it's just the noise in the background from the sensor itself. The warmer the temperature, the more the noise, and the cooler the temperature, the less. So that's why the temperature matters when you take the dark frames. So I did take the dark frames before the session, and we're applying those now. So let's take a look. We've stacked 30 frames so far. We've been 5 minutes into the exposure. So this is about what I'll normally do and probably stop here. This has been an excellent stack. The drift has been really, really low on this one, so we're going to, I think I'm going to go ahead and save it. I'll look at changing the histogram here just a little bit more and see if maybe we can pull some of the sky glow out, make it a little darker in the background. You can hold down the shift key and adjust that more precisely. Give us a darker sky. Yeah, that's really nice. I'm really impressed with this photo. This is definitely the best one I've got to date. Yeah, we'll bring this back just a little bit. I like to see the nebula. So we're going to do a couple things. I'm going to save this for record just so I have it. I like to compare from night to night what I saw. You never know, you might discover something new. I'm going to save the stack because I may play with it later. And then I'm also going to save the image as we see it on the screen. Great. Do that once more. Alright, so I'm going to pause that. We'll take one more zoom at this and take a look. But again, this is the Ring Nebula, M57. It is located, I will take it in the constellation of Lyra. It's right next to the really bright star Vega and is close to overhead, the Summer Triangle. It's comprised of Vega, Altair, and Deneb, which is here. It's a nice star field in the Milky Way that runs by this time of the year. I think did I mention how far? Let's see how far this is. It tells us the distance. This is in our galaxy. I do not see. Oh, there we go. So it looks like we're about 3,000 light years. Is the distance on this one. Alright, let's take a look around and see what else we're going to take a peek at tonight. And hold on, I'm going to take a quick little break and talk to my daughter for just a moment. Alright, I'm back. Let's see where we want to go from here. We can't go too far west or northwest, so we're going to have to stay more to the southwest. Let's look at maybe over there. Trying to find something in the M catalog. Alright, we'll go to the Wild Duck cluster. This looks like to be an open star cluster. So we'll see what we have here. It is M11. So we'll go ahead and get out of live mode here. I can only hope that the tracking on the mount will be as good everywhere else as it was there. Oh, I'll tell you what, before we go there, I had written down on my list, speaking of the mount, let's talk about what I have here. So this is a refracting telescope. It's actually small. Most people would think that I would be using a larger scope. This is an 80 millimeter or about 3-inch aperture. So the aperture is the diameter of the lens, not the length. The length is 560 millimeters, which is the optical length, not necessarily the physical length of the tube, which produces an f ratio of about f of 7. That's normal. It's a little bit slower scope. So what I've done is I've put on down here at the bottom this focal reducer that's inserted. It's black, and what it does is it changes the focal length to be shorter, 448 millimeters, and that brings my f number down, which means I can expose for a shorter amount of time. And I'll tell you why that's important in just a second. I'm on a Skywatcher AZ GTI alt-azimuth mount, and that's here. It's battery operated over Wi-Fi, so the only cable I have is going to this red thing, which is my camera, which is the Zoo ASI 120 MC-S. It's a 1/3 inch sensor, really small sensor, CMOS camera. This was an entry-level planetary camera, so what we're doing with it tonight is really not the wheelhouse, not what it's designed for. It's really designed for planetary imaging, and so it has a small sensor, and because of that small sensor, the field of view that I get is small. And that matters, as you saw earlier, when we're trying to find things. It's like you're trying to look through a small tube, and as you're moving around, it's hard to find the things. So I plan on getting a camera with a larger sensor that'll give me a larger field of view, and that way you won't have to be as precise when going back and forth, and then those problems with finding things should be more easily solved. It's also, if you remember when we tried to do a plate solve a few minutes ago, there weren't enough stars. Well, the larger field of view probably would have yielded more stars, and we would have been able to do the plate solve on that one. And the reason a lot of all this is important is this Skywatcher AZ GTI mount. It's a go-to mount. It's computerized. It's not really meant for astrophotography. So doing what I'm doing with it tonight is really squeezing out every last ounce of I guess the features and whatever capabilities it has. And actually I'm not even doing that. Other people have done even more with mounting this equatorially. So I'll probably examine that later. But it's been tracking well in the last few minutes, so we'll see how well it does. But because it doesn't track very well, my exposure times need to be short. That's why I said that I would explain all this. The subpar mount means short exposures. Well, with short exposures, I want to gather as much light as I can so that I can see more. With a f7, for the same exposure time, you get less light. So this focal reducer does two things for me. It gives me the bigger field of view, and then it gives me more light for the same exposure time. So those things all help me combat the fact that I have a small camera and a mount that's not necessarily designed for this. These are all very inexpensive. This mount is less than $400. This optical assembly is about $400. A reducer is about $100, and this camera can be found. It's actually discontinued now, but it's about $100. So these are not expensive in the grand scheme of things when you consider that there are mounts that cost thousands of dollars, and optical tube assemblies that cost thousands of dollars, and cameras that cost thousands of dollars. People that are buying those are usually buying those for astrophotography, for the really nice pretty pictures. So let's get back to some observing. We wanted to go to the wild duck cluster M11, so let's go ahead and type that here in the screen. Click go to. We'll see what we get. At this point, I'll just do a plate solve everywhere we go to make sure that we're where we want to be. And since this one is a cluster of stars, I really won't know exactly where the center of it is, so I won't confirm its center with the SenScan app. So let's see what we get. Oh, I can see that it's close as it streaks across. So we're not too bad. We have to wait, since I have a 10-second exposure, we have to basically wait 10 seconds at a time to see how that's working. And a lot of times what I'll do here is just, there we go. Oh, just quickly, let's take a snapshot of that real quick, if we can grab it. It looks like a satellite traveled through the bottom of the screen, so I think I grabbed it before it went away. Great, nice little cluster. It is a little offset, so what I'm going to do is turn crosshairs on for a moment and turn down the exposure some. I don't care that I see all the stars, just enough that I can get a reference, and I know that this one star is almost to the center. So if I can just keep it visible, that's all I need, and then we'll move it over to where it's in the center, or close to the center. Let's turn that down a little bit. I'm slewing too much. Perfect. Now we'll let the mount settle down for a moment. A lot of times after you do movements, it seems like it takes it a few moments to settle in. So it looks like we've settled in nicely. We're going to turn the exposure back up to 10 seconds. And we'll be close to center, not quite, but close enough. And see, 10 seconds, 65. There we go. Okay. So we'll go ahead and turn the live stack mode on and clear. Oh, before I do that, I almost broke my own rule here. We want to turn this to M11, so we'll catalog it correctly. We're going to clear, start a new stack. Nice. So I usually just let the first few frames gather before I really do any adjustments, because at that point you're just chasing each new frame that comes in. We can see quite a few stars. This is in the very rich part of the Milky Way, so as you can see here in the zoomed in part of Stellarium, we are right in the thick of the summer Milky Way here. So that's why we see so many stars in the background here. Right, now that we have a few frames, well, we have 5 frames stacked, so we're going to move this over so we can darken that background a little bit. And we'll just continually adjust it as the new frames come in. We may be a little too much on the green side, so we're going to pull down the green just a tad. There we go. I tend to prefer bluer colors myself, so I may end up with a bad habit of overexposing blue just because it's my favorite color and I like bluer stars. But you can clearly see in the picture that we have different star colors. This is a nice open cluster. We'll try to look at a globular cluster before we end the live stream, so we'll take a look at that next. But the difference is that the open clusters, they just tend to be kind of scattered and there's no really form to them. The globular clusters are like it's like a little ball that they're spherical in shape. So this one's maybe, even though they are sort of all together, they don't have a necessarily defined shape to them. You'll be able to see the difference whenever we do one of the globular clusters, but that's the main difference. We won't do any nebula tonight. This camera and the exposures that I have are just not really good for the nebula that I have available. I'm sure the Orion Nebula would look good, but I'll probably have a new camera soon, and when I do, we'll try the nebula with that. They'll be more sensitive. All right, let's make some more adjustments. So we have more frames in. I really like this one. We're going to zoom in a little bit and see what we can see. Quite a few stars here. I love the fact that you can see the colors and just so many of the stars that are right next to each other. And I know that sometimes these look like they're next to each other, but they're really, it's just the perspective. They're, in the same line of sight, not necessarily next to each other. But I do wonder if some of these that are really close happen to be orbiting each other. But you can really see the distinct stars, and again, the mount is really tracking superbly tonight for what it is. And and that helps to be able to see all these individual stars rather than when it's not tracking. Sometimes they'll be oblong rather than tight circles. So that's real promising. I probably could expose for longer than 10 seconds tonight with the way the mount is working. I should have created some darks at the 15-second mark and see what I can get. So let's zoom back out. If you have any questions, go ahead and put them in the chat. I'll be more than happy to address them. I see 2 people watching. I think I'm one of them. So whoever you are, thank you. Let's come back to 100%. Yeah, you can see we've got a little rotation because of the black bar at the bottom here. But still, it's a really nice tight cluster with good pinpoints of light. So you can understand why the mount is so important with astrophotography in general, or more in electronically assisted astronomy, because if the tracking's not there, you're going to end up with lower exposure times, or your stars are going to be trailed, and you don't want to see that. Alright, we're at the 5-minute mark, so usually there I start thinking about how I'm going to save the image. And really, this one's stacked up quite nicely. I think I'm going to save it just like it is. And we'll save it exactly as seen. And just to show you, when we save these, basically what it does is it puts them in a folder, and with tonight's date, and see it catalogs them. That's the importance of the catalog, and get it processed, and you'll be able to see here. You'll open it on the other screen. Hold on just a second. We'll pull it over. There you go. And so you can share that picture. It can be post-processed, but I don't want to do that. It moves from the realm of EAA to real astrophotography. Oh, let's see. There's Rob. Hey, Rob. I will keep it coming. We'll try to look at some other things. I'm glad you joined us. Alright, so let's move on. Let's take a look at something else. I'll grab out of the live stack here. I said we would look at a globular cluster, so let's find one. I think there's a nice one in this area. It's too close to the horizon. We won't get that one. What's this one here? Well, I've never looked at that one before, so let's take a look and see what it is. We'll go back here. Well, that's interesting. The won't allow me to select the catalog here. So tell you what we'll do. I told you that previously that we could actually control the telescope from the Stellarium software, so let's give it a try. I think it's Control 1. Yeah. And we'll see how it does. With any luck, we'll be close. Yeah, I think I can see it there coming in the center. Let's turn the exposure down a little bit until we get things straightened out on the mount. It doesn't look like we grabbed quite onto it, so let's a little more exposure, and it looks like I'll probably plate solve for this one. Oh, or maybe not. It's there. It's just a very faint one, it looks like. Helps to know what you're looking for. we'll go ahead and plate solve just to be certain, but I'm pretty sure that right here, just to the right of center, is that globular star cluster. Not necessarily the most spectacular one, but it looks like it is there. Let me go up to 10 seconds just to be sure. Yeah, that's what it is. So it's just one of the fainter ones. We'll go ahead and capture it. May not spend as much time. Oh, didn't grab the right. NGC 6712. We'll go ahead and do a live stack and clear the previous one. Let's see what we get with that one. There are more spectacular ones out there. I'll find one. But yeah, that's definitely what that is, no doubt. So we'll give it a few frames to get in here. Just such a starry field, that whole area has so many stars. We're getting ready to get into this time between the fall and winter, where there are not as many stars in the sky until we get over toward midwinter and we start seeing another part of the Milky Way during the normal evening hours. Alright, let's see what we can do. It looks like color's okay. So it's really just a matter of waiting for these frames to come in, adjust the histogram, and see what I like. I guess in this case, really it's probably a perspective. This cluster doesn't seem as spectacular as some of the other clusters, but it's probably because there are so many other stars around it already. Some of the other clusters have more dark space around them, so that the cluster itself stands out a little more prominently. We'll let that get a few more frames, and we'll find another one. While I'm waiting, tonight has been assisted by some bourbon. I will probably, each time I do one of these, try a different one. Tonight's bourbon is Blanton's Single Barrel. It is, I think, 93 proof, so it's a nice selection for the evening. Very smooth. I think Rob will appreciate that. We'll do a little more adjusting here, and we're going to move on. I think you guys will like a more prominent cluster. I want to get to them before they move out of the view. So let's go ahead and pause this one, and I'm going to save it. And let's look for something else here. Okay, we'll move across. I really would like M55, but it's just too close to the horizon. So we're going to come over here into Capricornus. Well, this is another one I don't think that I've looked at before. M30. Let's see what. Well, we can give it a try. Let's see if the software here will let me. 30. We'll go to. We'll see what we get. That's why we're here. That's what observing is about. Looking at new things and seeing exactly what's out there. And I'm doing this all from a heated room. In the wintertime, that's the best part about this. I've actually wanted to do something like this since I was a child, but really this type of thing did not exist. Obviously the technology didn't exist when I was a child, so as an adult it's nice that this technology has come of age to be able to do something like this, to sit in your home and pull up pictures on your screen. So this one's going to be, looks like a smaller, tighter globular cluster. It wasn't too far off. We're going to turn the exposure down for a second and bring it down to the middle of the screen. Turn the crosshairs on so that. Yeah, I don't do cigars, Rob. Yeah, so you can be jealous of the bourbon, but no cigar pipe. I'll have to find someone. Maybe I can if you do that, maybe you can come over and we can tag team it, and you can smoke the cigar or pipe, and I'll drink the bourbon. And I'll share with you though. All right. I think that's close enough to center. So let's turn the exposure back up. As I go across and look at these targets, you can see there definitely is a method that you go through. You know, turn the exposure down, move it, turn it back up, and those kinds of things. Experiment. You know, 10 seconds the exposure's not. Like, the mount has been doing well. I wished I had gone for 12 seconds or 15. In fact, you know, we can do that. Interesting enough, the darks won't match it, but that's not necessarily a huge thing. Let's just do 15 and see if we get any trails, or if the image is still pinpoint. If it's still pinpoint, we'll just stack with 15-second images. I have done that before on this mount and camera combination. Deal. Okay. I'm sure that I noticed that this live stream is probably delayed, so if when you type something it's like 5 minutes before I see it, it's because of the delay. I think we can do something with that, so we'll stay at 15 seconds. And I already typed, yep, M30, so we'll go to live stack, and we're going to clear, and we'll start a new one and see what we get. Alright, definitely needed to adjust the histogram on this one. Very interesting. Looks like we might have more noise because of the extra exposure. But it's interesting. I can see where they get the name jellyfish cluster, and it does look like there are tentacles coming down. Looks like maybe 3 of them. A left one, a center one, and the right one kind of curves. So that makes sense why it would be called the jellyfish cluster. This one is about 27,000 light years away. Light years about 6 trillion miles. So get your calculator out. 27,000 times 6 million, and that's how far away it is. That's why it seems it's a smaller one. There are clusters like this that are closer that are, again, are more spectacular. So a talk like this is not spectacular. I like this one. It's different. But there are some that are just really nice and big and have a lot more stars. And so we'll find one of those in a moment. Looks like we can expose blue just a little more maybe. Or I can turn down red. That's what I need to do. I already turned it up earlier, so let's turn the red down and the green. Let's see if they don't catch up with the blue a bit. Don't want to. Too much blue is a bad thing. We'll go with that. So that's not too bad. That's producing a pleasing image. As I drag this mid-level slider over, it seems to looks like more stars are showing up, but it also brightens the background. So it's always the trade-off. You brighten the background, you see more stars. You darken it, you see less. That's where if you had a better mount with more exposure time, you can get the best of both worlds. But again, I'm not going to complain too much because this mount has been really performing nicely tonight. We'll let this one expose for a little bit more, and we'll find another one. We'll go ahead and look while it's exposing. Try this Pegasus cluster. Where my mount has been having issues is stuff that's closer to overhead. So we'll see. We'll head over to this one here in just a minute and see what it might look like. Let's do a couple more adjustments here and we'll do that. Again, Shift key helps you to make more minor adjustments, small movements. Alright, we'll be happy with that one for now. I'm going to pause that, save. We'll exit from here. I'll go ahead before I forget and type the catalog number. And let's go over to Pegasus, M15. You might even be able to hear the telescope moving around right now. Alright, we should be close. Let's wait for that first image or two to come in. Too much. Let's go back. I haven't had to do a plate solve in a while, but it looks like we might have to do one here. Yep. Let's do a plate solve here. See if that's still working okay. Again, if you... Oh, I missed it. What was the bright blue star to the left? That was probably when we were looking at the jellyfish. Alright, let's see here. Lost my bearings here. We're looking at jellyfish. Wasn't here, was it? No. How about we just do a search? Nope, that wasn't right. What was that last one? We'll take a quick peek here. It was... Is it M11, right? 1021, no. M30, okay. Let's take a look here. I'll bring this on the screen. Alright, so you were probably talking about this bright blue star. Right. Okay, so it was, in fact, M30. So let's go back over here. Do a quick search. We will find out what the name of that star is. Alright. Because the images are flipped, it's going to be this star here. It's a hip star. So apparently, because I don't think it's close enough to be 41 Capricorn double star. No, it's not. It's this one. You can tell because there's this pattern: bright, not so bright, brighter, and the same thing here: bright, not so bright, brighter. So it's a little tad flipped. So this is definitely it. So it's HIP 106977. It's just so faint that it's not going to have a proper name. If I can even... Looks like it has a... there we go. Yeah, it's a magnitude of 8.6. So the magnitude system goes... actually, the lower the number, the brighter. The higher the number, it's dimmer. If you were at a dark sky location... where there are no city lights and you had your pupils completely dilated, you could see down to about magnitude 6. And so this one's magnitude 8, so it's far beyond the unaided human eye. So you would need something, binoculars, telescope to even see this. So for the most part, the stars that can't be seen with the naked eye have numbers as names rather than real names. The ones that have all the real names were named years ago by all of our ancestors. So that's the blue star. Oh, seems 11.5 degrees off. Let's try and see what went on. The mount did not like where it went to. The software didn't like where the mount was. So let's see. It is not really happy. I don't think that the mount is in a good place right now. So we will. Oh, there it is. It's really close to the horizon, but we'll stay there. We got some sky glow behind it. M2 is where we should have gone, possibly. Yeah, that's okay. Yeah, let's go up to M2. Because we're really close to the horizon over here. I'm just looking out the window and I can see we're pointing almost over top of the building next door. So let's see if we can get higher up in the sky. This will probably be the last target. Well, we'll see. If this one behaves okay, we might swing over to the Andromeda Galaxy really quickly. Ah, okay. You can see the cluster there in the center of the screen. And looks like it's just off the screen, so we're going to bring it over a little bit. And we'll go down. There we go. I like that position. So this one's definitely more like the typical globular cluster. You can just see that really heavy concentration in the center. Let's change our name here and we'll start stacking. And it just looks like a nice round ball. Very symmetrical in shape. Let's reset this one. Alright, we'll let a few more frames come in. There are tons of these types of clusters throughout the night sky, and there's one that's really nice. It's considered the best one of all, but it's just outside of the view. So it's really impressive even in the larger size telescope. And in fact, some of these things we look at, the views are different visually, but it's just a different aspect and a different way to see them. It can be impressive in its own way in a telescope, even though you may not see all of these stars like we're seeing on the screen. Looking at it with your eye, it's more crisp, I'll say that. Some of the stars that we see here become bloated because of all the pixels and all that kind of thing, but when you look at a star, or look at a star in the telescope, they're just little pinpricks of light, and it's just really neat to look at some of these star fields and see so many stars that even the camera isn't quite picking up on sometimes. All right, must have a really nice dark sky because in the far left-hand side of this histogram is not really moving. If you really were paying attention before, you would see that this curve would go up and then down, and sometimes it would come up and down again. That's usually the background in the sky, from what I understand. Could be wrong, but I think that's what it is. And so this one, with no sky glow in the background, it seems like everything's shifted toward that left-hand side. Let's zoom in a little more on this one since it's a smaller one. You can see all those little stars. I'm sure that the 15 seconds is helping us a little bit there because of it being a smaller one. Interesting. I just noticed that it says we could not align could not stack. So we have this problem every now and then where it can't find alignment stars and won't stack. So that may be why the histogram isn't working. I didn't notice that till just now. Let's pull back out of this and find out what happened. It could be that the image moved off the screen. Ah, look. Why didn't someone tell me? Morgan requests for the moon the next session. Yeah, we can do the moon actually. That one's the planets are harder to do because they require a different way, a different type of imaging. But we can definitely do the moon. So let's get this back up exposure-wise and clear this out and try again. Goofed up and didn't even reset the exposure. There we go. That's more like what I was expecting. And it looks nicer that way. Yeah, I think the moon is probably, well, I saw Morgan post a picture on Facebook, so it's a thin crescent in the morning time right now. So it'll be new moon, so probably in about a week to 10 days it will be in view for this time of the night. It actually washes out a lot of this kind of stuff and makes it hard to do this. So when it is out, sometimes it's just best to accept what you have and go ahead and look at the moon while you have it, and then come back to this kind of stuff when you have a dark sky. Yeah, this cluster is definitely more impressive when you expose it for longer. I don't know why I didn't notice that I only had it at that 2.7 seconds. That's the downside of shifting the exposure back and forth, trying to center things and get them back. You can forget where you are and not have the settings where you need them to be. Yeah, we'll stack this one for a few more frames and then we'll try to swing over. The Andromeda Galaxy is actually so big that it will not fit. We'll zoom in here. It will not fit on my sensor. In fact, my sensor just barely. I think I have a. Yep, this square box basically shows what the sensor on my camera can show field of view wise. So when we're looking up at the night sky, you can see how much what the small slice is. When we go over here and look at the Andromeda Galaxy, we're gonna zoom in on this, and you can see that it's the majority of it is actually outside the sensor. But we'll take a peek anyways. This one is more spectacular when astrophotography, but really, I mean, even with EAA it would work good. I just don't have a proper sensor. You need either a small focal length with less, which creates basically less zoom, and a larger sensor. But like I said, next session I may have a new camera, and that camera will have a larger field of view and enable us to see some of these things. Alright, let's take a peek here at this one. We'll finish it up and move over. I have to work tomorrow, so I probably should wrap this up soon. And little Stella might have been staying awake too. There we go. Just get some of that darkness there. I like that one. So we'll pause it there and save it. And we'll finish off the bourbon. Well, maybe one more sip after this. And let's take a look at the Andromeda Galaxy and see if the tracking holds up on the mount in that area of the sky. Then maybe we can see what it has to offer tonight. We'll make that the last target. So we've managed tonight to look at a planetary nebula, an open cluster, a few globular clusters, and hopefully a galaxy here in just a minute. I don't know if I mentioned it earlier, but this one is 2 million light years away, but is actually considered like a local cluster with us. So it is still our neighbor. Our galaxy, if you could look at our galaxy from the same vantage point as we are looking at Andromeda, is similar to this. We have more of what's called a barred spiral galaxy, so it'll be kind of a bar across the center. But otherwise, we are very similar in structure. Well, let's see how the mount's going to do. Looks like right now it's still kind of giving me star trails. Yeah, it seems like this side of the sky tends to have a difficulty, but we definitely didn't get Andromeda, so let's do a plate solve real quick. Turn up the gain. And change the histogram here. Get a few more stars in and see if we can do a plate solve and get where we need to be. I think the reason that it's not tracking as well is because Andromeda is basically on the other side of the sky. So when doing these sessions, it probably helps to stay in one section of the sky and move around that area, and you get good tracking. But once you kind of flip over to the other side, the mount seems to be not so accurate. So let's see if we can get a solve here and get on target. If we do, I'll tell the mount where it is, so maybe it'll track better. Come on, find it, find it, find it. I found that with the plate solving that normally, if it doesn't find it in the first, I don't know, 20-25 seconds, that it usually isn't going to. So I'll have to cancel it and try again. Let's cancel and try again. When I first did my first couple of sessions with this, without plate solving, you can imagine, basically the method was you put the eyepiece in the telescope, center it with the eyepiece visually, and then at that point in time I had the laptop outside, so I didn't have the inside set up, but basically you carefully remove the eyepiece and carefully put the camera in its place. Then you'd have to refocus and go through all that again because the eyepiece focuses at a different plane than the camera does. So it was just a hassle. So this plate solving, when it's working correctly, really helps out. It's odd that it's not doing well right now because we are really, we have quite a few stars. Normally this is enough stars to take care of the plate solve. Let's expose for a few more seconds, see if I can get a few more stars. Alright, let's see if that will help. We'll try one more time. Third time's a charm. Finish the bourbon on that sip. And fingers crossed. It doesn't look like it's going to solve. Interesting. Alright, well, see if we can go with plan B here. Go to the Triangulum Galaxy, just so we can see a galaxy. Maybe we'll grab that one. If not, we'll call it a night. It's unfortunate because the mount does seem to be tracking okay in that area now that it's stabilized. So, but that's okay. Andromeda will be in the sky for a while. We'll have plenty more chances to look at that one. So let's try this last one, called the Triangulum Galaxy. So whereas Andromeda we sort of had an edge-on view, this one's instead of, so I'll show the camera here, we had a sort of a view like this of Andromeda, so the Triangulum was like flat, so we're looking like from above it. And we'll likely have to do a plate solve here too, but hopefully it will work. We'll get to see this galaxy. Let's try it one more time. Everybody that's watching, all two of you, keep your fingers crossed. Alright, here we go. Got good tracking, so I hope we find it. Like the Ring Nebula, I'll probably get the best view that I've had of this galaxy if we can just find it. Yeah, it's not looking like it's going to. The mountain just must be really off base right now as far as where it is relative to the target. Let me just try a couple more things. Go up to 15 seconds. Stretch the histogram a bit and see if we can't find a few more stars for it. But if that doesn't work, we'll chalk it up. There's always next time. We can't view all the targets in one session. We wouldn't have anything to view the next session. So let's move this around just a bit. We'll try one more solve. Yep, fingers crossed, Rob. Fingers crossed. Something strange happened there, but we'll see. Everything got dark all of a sudden. Come on, find it, find it. I was just bragging on the software and how helpful it is. Now it's decided that it doesn't want to work well. I'm sure it's not the software, it's just probably we're just too far off base. The way this works, it really wants you to be semi-close to the object, and it searches within a small area around that object. Let's see if I can look at the star chart real quick and get any indication of where we are close to this. Gosh, there's just too many stars. This is the galaxy that I'm trying to pull in right now. And I have successfully done it before, but it's just not looking like it's in the cards tonight. We'll try one more thing. I'm too persistent. We'll try to get to Mars, and maybe if we can get to Mars, pun intended there, we might get an alignment good enough to get us to one of the other places. So let's try that out. It's close enough, and it's bright enough, so it'll be easy to find. And verdict is clearly the mount is not quite where it needs to be. That's the problem. And they're definitely, oh, but look, aha, I can see down low there's a glow. I bet that is Mars, so we're going to follow that glow. Let's see if I get lucky. Aha! Yay! So let's center that. I think I said earlier in the stream that you like to center every so often, and the last few targets I did not center and tell the mount that it was centered. So, haha, Rob, it's not in the stars tonight. I like that. I'll write that one down. Okay. So it knows where Mars is. One more time. Feeling lucky this time. I feel like those same two groupings of stars were in the last picture. It's taking us to almost the same space. Let's make sure that the galaxy isn't there and I'm just not seeing it because of patience and exposure. That galaxy is really faint. Nope, not quite there. Right, but we might have better data for a plate solve this time. So let's try it once more. Drum roll, please. If you watched Christmas Vacation, National Lampoons, you know what I'm talking about. We'll know in 20 seconds. If not, well, like I said, we'll save it for next time. It'll be suspense. It'll give you a reason to come back. Got to leave people wanting more, right? Give them everything they want the first time, they won't come back. Yep, not going to happen. So, it's a nice star field. That's what we're looking at now. We'll try for some galaxies the next time. And besides, like I said, I'll likely have a better camera, and that camera will do better with galaxies, so we'll get to see a little better than they would have looked tonight anyways. So I think I'm going to wrap it up for tonight, and hope that you have enjoyed. Oh, is Mars too bright for the equipment? No, it is not. What it is that it's I had the exposure turned up real quick before I turn off the live stream. So the way we view the planets is just a tad different than viewing. It's actually just the opposite of the way we're viewing some of these fainter objects. The fainter objects, I'm exposing them for multiple seconds, 10, 15, in this case even 16 seconds right now, so that we can gather as much light as possible because they're faint. For the planets, what we do is you actually expose them for a really, really short, like milliseconds. And you take a video, so you may capture like 300 frames in a second of Mars. And what you're hoping for is that in a few of those frames, there was a slight moment where the turbulence in the atmosphere was gone. It was steady, because that's really what limits us to seeing the planets up close right now, is the turbulence in the atmosphere. So you hope for a few really good moments of what they call seeing, and when that happens, you've captured it in one of those frames. And there's some stacking software that you throw these. So I may expose Mars for 5 minutes at 300 frames a second, and so I don't know, 70,000 frames. So it's basically like 70,000 pictures of Mars. And this software looks through all 70,000 of them, and it picks out the best ones and says, okay, these were good, these are bad, and so we get rid of all the bad ones, and then it stacks them all on top of each other, does some crazy mathematical calculations, and then gives us an image. So that's technically outside the realm of what's called EAA for assisted astronomy, because for the electronically assisted astronomy, we want to we don't do post processing. So basically, what you see on the screen while you're viewing is what you get. People do look at the planets in this manner, but there's not much detail. You know, real quick, I'll go over there and show you, but it's just hard to get any detail out of Mars with just one frame. So you can see I'm going to turn the exposure down really low, because as you noticed, it was a really bright, overblown image whenever we looked at it a minute ago. Oh, so we're at 1,000 milliseconds, so I'm going to turn it into short mode here. We're going to come down. So as you can see, I have the gain turned up too. So we normally don't need to turn gain up. So we turn that gain all the way down, and we'll try. So this is a very small image scale right now, because if you recall, I don't know how long you've been on the live stream, I have a thing called a focal reducer that's actually changing the focal length really short, so that I can have short exposure times on these other objects. The downside is the magnification is really low. So for Mars, I want higher magnification. So if I really wanted to look at Mars, what I would need to do is take that focal reducer off and put a thing on called a Barlow lens, and it's the exact opposite of a reducer. Instead of making the focal length shorter and thus low magnification, it's going to make the focal length longer and give us higher magnification. At that point in time, I could change this exposure around like I have now and actually get more than this little pixelated image that you see on the screen. But strangely enough, the darkness that you're seeing right there is in fact the markings on Mars. So it's not that we can't see any detail. It's really pixelated. And all that jumpiness that you're seeing on it is the turbulence in the air. But we are seeing some of those. It looks like that red thing right there might be a hot pixel, so ignore that. But those darker colors are actually, let's see if I can move it away from those hot pixels. There we go. So yeah, there is some small detail. You're looking at it live right now through the telescope. I don't know if there's any life there, but there are those dark areas. I don't know if those are the dust storms. I'll have to do some more research on Mars. So it finally told me that it couldn't find the galaxy from earlier. But anyways, yeah, we can do maybe one night I'll do a session, not necessarily an EAA because it technically wouldn't fall under that, but I can do a session with imaging one of the planets and show you how that works. Again, a lot of it's post-processing. What I'll normally do is spend time, like right now, I would sit here and capture those 70,000 frames and do that 3 or 4 times with different settings, and then bring the telescope in, set it, get it all put up and all the dew wiped off and everything, and then go through the post-processing software and try to get the details out of it. But my little telescope that I'm using for all this actually isn't the best option for planetary, but it does fairly good for what it is. So with that, I think it's 11:08. I think I'll wrap it up, and thank you for viewing tonight. Hope to do it again, and hopefully everyone will enjoy. Let's see. Last comment. Great Netflix documentary on Mars rover available. I'll have to check that out. I've been watching the right stuff, the reboot around the Mercury program, so we'll have to put that one on the list later. So